Hey everyone! Welcome to the Pitch Off. Now, I know these interviews have been great, but this is going to be the best part of the show. I absolutely promise that. TechCrunch has long featured early-stage companies, and we do this through multiple ways, including pitch-offs. Since 2008, we featured over 1,000 companies in our marquee program called Startup Battlefield, and that takes place every Disrupt. So next year, in 2023, we're going to have a brand new batch of companies presenting at Disrupt. But today, you're going to see 3 companies present. And now these are early-stage companies. Most of them have raised seed funds. Some of them have MVPs, but they're early. The judges are going to be evaluating the companies based on their potential for impact on either socially or financially. So you there, while you're sitting and watching, think as a venture capitalist. Think that these guys are coming in to see you in your office. They're going to pitch to you for 4 minutes with a deck. And then think through their process. Which one of these companies will have the best potential for impact? So with that, I'm going to bring out the 3 judges, and then we're going to bring out the companies. Okay. Judge number 1, we have, are they coming out? Yes. We have Mark Bogut from Seraphim Space. Mark is a pioneer in space tech, having co-founded Seraphim Space Manager, Generational Space, Space Accelerator, and so much more. He's been a fund representative on boards of a range of global space tech companies, including Leo Labs, Spire Global, and Hawkeye 360. Next, we have Tess Hatch. You might know Tess from the last 2 hours of the program, and she's also a partner at Bessemer Partners, where she helps foster entrepreneurship in frontier technologies, specifically the commercialization of space, drones, autonomous vehicles, and food technology. She currently serves on the board of Drone Deploy, Iris Automation, Phantom Auto, and Spire Global. Lastly, we have Emily Henriksen, principal at Root Ventures. At Root Ventures, she helps investments in 3 areas: tools and infrastructure, low-cost robotics, and hardware and data science. Prior to joining Root Ventures, she worked as a propulsion engineer and designed flight hardware for the SpaceX Falcon and supervised builds for scheduled critical missions. With that, I'm going to go over the interviews format one more time, and then we'll bring out the first companies. These companies are going to present for 4 minutes, and then they're going to get 6 minutes of questions and answers from the judges. All right. So the first company presenting, we have ArcRift. Presenting for ArcRift is founder and CEO Emily. Come on out, Emily. I don't know which way they're coming. There she is. All right, Emily, the clock's right down there. You have 4 minutes starting now.
Cool. The space gold rush is here. From space tourism to future commercial space stations, more and more people are visiting space. But space is dangerous. Accidents like depressurizations can and will happen. And the equipment we're using to protect people in vehicles is very outdated. Spacesuits haven't fundamentally changed in over 60 years. And all of the spacesuits and safety technology we have was built for NASA to protect government astronauts. And obviously the needs of government astronauts are much different from those of commercial astronauts and commercial launch providers. ArcRift will be the Levi's of space. We're building technology to protect the next generation of astronauts. Commercial astronauts care much more about experience than government astronauts. And with that in mind, we've made our first product, which is an instant emergency space helmet. Our proprietary helmet technology can protect people of any skill level without impeding their experience or their work. The way it works is it stows completely away, and in an emergency, automatically deploys to provide supplemental oxygen and impact resistance. For the past 3 years, we've tested many different methods of deployment, and the one we've currently settled on is a spring-based deployment mechanism, which will work well in an unpredictable and rapidly changing pressure environment. Ship alarms will trigger deployment in an emergency, and the dome will be clear to allow for greater visibility. The helmet can be integrated into a flight suit for suborbital flight, or replace a helmet of an existing IVA suit for orbital flights. We have 5 provisional patents, and we're one of the only companies in the country working on spacesuit technology. Currently, if you want to go to space, there are 2 intra-vehicle safety options: quick-on oxygen masks, which are usually used for suborbital commercial flights, or full IVA suits, which are usually used for orbital and NASA commercial crew flights. Quick-down oxygen masks require passengers to find and put them on in an emergency. Given their limited amount of training and the fact that useful consciousness in a depressurization is only about 5 to 10 seconds, this is a super bad idea. Full IVA suits, on the other hand, are safer, but they're incredibly expensive, uncomfortable, heavy, and their helmets suck. IVA suit helmets don't turn with your head and severely limit your field of view. Since our helmet stows until needed, you have an unobstructed view of everything around you. Since it deploys automatically, it doesn't require any training to use, and it will be less prone to user error. Our beachhead market is suborbital commercial spaceflight. We expect this to grow a lot in the coming years, given all of the space projects in the works that will require humans living and working in space. Using what we've learned in space, we plan on adapting our deployment mechanism for use in high-risk terrestrial jobs, like chemical plants and mines. We chose space as our beachhead because it's an emerging market, so it's easier to enter and we can do the most good there. Also, having a space-proven helmet will help us differentiate us in the industrial safety market. We are constantly building and testing new prototypes, but we plan on doing our final validation testing to go to space next year and go to market in early 2024. If you would like to join us in being part of the future of space, feel free to reach out. Thank you.
Thank you very much. That was very good, Emily. Thank you. Mark, let's start with you with the first question.
Yeah, so Emily, well presented, and what an interesting business that you have there. So we're investors in people, so I'm interested in your backstory. What was the catalyst for you creating this business? How did you lead to that point?
Yeah, so I've been interested in space my entire life. I love space. And I was a bit concerned about the safety of commercial launch providers. And obviously we're sending less trained people up. And I was like, hey, this is gonna get dangerous if we don't have technology to protect them. And I was in college at the time. And I was like, hey, I could just build something better instead of just being concerned about it. So I founded this when I was 20 and in undergrad. And we got grant funding while I was still in school. And it's been about 4 years now.
Thank you. Emily?
Yeah, I have a question just about the product and the technology and how it works exactly. So is the helmet, I understand it's like a spring mechanism that sort of deploys if there's, I assume, a drop in oxygen in a station or a shuttle. Is the source of the oxygen, is that something that the astronaut would wear, or is it more centrally located and then they walk around with tethers? I'm just trying to understand how someone wears the full product.
So we're probably going to do tank oxygen attached to it because we have done a lot of interviews with commercial astronauts, both people who've been to space and people who are going to space.
Yep.
And the one thing they keep saying is it can't be tethered. I want to float around.
Yeah.
So we're probably going to do a tank. We have looked into chemical oxygen generation, but obviously that's super exothermic and probably a bad idea. So, cool.
Tess?
Great presentation, Emily.
Thank you.
Help me understand who you're going to sell this to, especially because the existing spacesuits or companies that are sending people to space have already designed their own.
So we're targeting suborbital, commercial, space tourism companies, so Blue Origin, Virgin Galactic, and that's our beachhead. SpaceX is really the only one who builds their suits in-house. Everyone else contracts for it, and there's only about 3 companies that will build you suits. So very few actually build in-house, surprisingly, especially for IVA suits.
Yeah.
Mark, do you have another question?
Yeah, absolutely. There's presumably a terrestrial market application for this. What is it, and why wouldn't you start there and then develop into space rather than starting with space and moving into other markets after?
Yeah, so there are terrestrial applications. We are starting with space because right now it's more of a safety risk, and terrestrial markets are very established, and they're very established large competitors, conglomerates we have to compete against. Whereas space, we can actually grow with that market, and we can get in now. And safety devices are very sticky. So it's kind of we go into space and kind of plan to long-term grow with that market, and then pivot into industrial safety, and then kind of scale in industrial safety. So then we're kind of planning our company for the next 50 years. But
So
we
there
can
are-
make a lot of money in like industrial safety in the next like 10.
So there are existing companies that are making this kind of capability terrestrially?
No.
There isn't?
I mean, we're replacing an emergency escape respirator, but that still requires you to find and put it on an emergency. So we're just basically automating an emergency escape respirator.
Thank you.
I got a question. I was hoping you can explain where you are in the process of the company. Have you deployed anything yet? Do you have customers?
So we're finishing up our prototyping right now. Kind of where we're at. We've been talking to a lot of people in the industry and kind of just finishing our prototyping.
Great, thank you. Tess, Emily?
Oh, I was gonna just say your vision of being the Levi's of space, I thought was very interesting. I'm curious, safety seems like a smart place to start, but I'm curious, what is the biggest version of this company to you? Like the Levi's of space sounds pretty cool. What other interesting space apparel and whether it be for safety or just performance or function, do you envision going into in the future?
Yeah, so we want to be the main supplier of all space safety. You go to space for any reason, you work in space, we're your supplier. And then also maybe move into consumer and do some fun things in consumer. But we're actually working on some side projects right now, also in space. So making a hydrochromatic suit. So most of the suits right now are white or blue. And if you bail out in the ocean, you can't see them very well. So we're trying to make a suit that changes color into international safety orange if they hit the water. So then we can rescue them more easily. So then you still have that style, but then you also have the safety function. So I think that's kind of our thesis is we want it to be stylish and we want it to be comfortable and look good, but we also want it to be as safe as humanly possible.
Tess, last question.
I was also going to double click on the product roadmap of what's next. Maybe then you had on your last slide the goals you're hoping to achieve in
Yes.
validation and quality testing, I believe. What about other from a company perspective?
Yeah.
Team, funding, et cetera.
Where are we planning to go or what?
Where
our
you're
team-
hoping to be a year from today if we were standing back here.
We are raising our seed, and right now we have about 2 people on our team, and we're going to build that out hopefully to a lot more. And after we're done with space helmets, we're probably going to move on to other suits and move on to industrial uses because we really want to build out our suit technology. So.
Great, thank you very much, Emily. Give them a round of applause. There's good energy in this room. I don't know if you know it, but I can feel it up here, and I appreciate that because it is really hard to come up here and present to you. You're literally all rocket scientists, and so it's great that they can come out, present to you, and make sure you give them good energy back. We have 2 more companies. Next, we have Fluix. Startup names are hard. Fluix? All right, come on out, Abby. All right, sir, there's your timer. You have 4 minutes starting now.
To start, I want to remind everyone of humanity's ever-growing dependence on data and communication, which is exponentially growing, by the way, with no signs of slowing down. All of this data is hosted within the global data center infrastructure. However, there's one huge problem with this infrastructure. Data centers are projected to consume 20% of the world's power consumption by 2040, 43% of which will be used to cool down servers alone. And although there have been advancements in liquid cooling, there needs to be further advancements in cooling to meet the data demand of tomorrow. Hi, I'm Abhi Sastry, CEO and founder of Fluix, and at Fluix, through nanotechnology liquid cooling, we're enabling data centers efficient enough to be powered by renewable energy and built anywhere on the planet. For Fluix, this is a huge opportunity, as the global data center infrastructure market is a $27 billion industry with major customers such as AWS, Google, and Microsoft. But as I mentioned, cooling technologies of today need to improve to meet the data demand of tomorrow. The 2 major drawbacks for even the most efficient cooling systems of today is they still use a significant amount of energy and moving parts to work. This is where Fluix is developing the next generation of cooling with our pumpless and self-boiling liquid cooler called Project Stellar. With our solution, we're eliminating a majority of moving parts, allowing cooling to have net zero energy consumption, but still being able to cool high-performance chips. And this is how we're doing it. The next secret in innovation of cooling is unlocked in microgravity, because we know that fluids and heat transfer behaves differently in space. Fluids don't boil in space. Instead, the bubbles created by the heat coalesce together and do not separate, leading to a lack of heat transfer. By solving this bubble separation problem, we'll be able to create an ultra-efficient coolant that allows for easier boiling here on space. This is our innovation. Fluix is developing proprietary nanosuspensions that have the ability for the nanoparticles to pierce bubbles in space, allowing for heat transfer. And we're already working with some of the top developers of the next generation space station to make this happen. Why are we so focused on microgravity? It's because there's no other viable substitute. On the basis of nanoparticle dispersion and showing nanoparticles piercing microbubbles, we have to bring light to the fact that intermolecular forces behave differently without gravity vector. And there's no easy way to simulate this using computational fluid dynamics. So there needs to be the ability for us to do a microgravity experiment. And we're proposing multiple missions to low Earth orbit with our partners to be able to do this. And having completed microgravity experiments, and when we optimize this fluid solution, we would be able to implement Project Stellar into the global data center infrastructure, enabling data centers so efficient they can be powered by renewable energy without having built anywhere on the planet, without having access to high complex power grids or large water sources. At Fluix, we have done $50,000 in revenue selling our coolers to computer manufacturers. We recently went through a Techstars Deep Tech Accelerator, and we're looking to build a larger engineering team. So for the engineers out there, please come and see me. And for the government partners and the companies out there, we're looking to build a lab. So if you're interested in helping us, please come see me after. At Fluix, we're unlocking the next generation of cooling for data centers through microgravity. Thank you.
Good pitch. You got Tess to lean into that one, so we're going to start with her.
Well, it's because I'm a little blind, so I was trying to read the slides without my glasses. I love this application. Manufacturing in space is usually pulling fiber optic cables and Z-band for comms. So I will be using another one where the effects of zero gravity has a very useful application. I'm curious, I saw, because I did read a little bit of it, that you did some tests on the ISS. At what scale, and you sold that, where are you at in terms of how much you're able to produce up there for meaningful use down here?
All that we have done so far, we haven't done any microgravity testing at this point. We've done mostly simulation testing. That's what we've found out how bad simulation models are in software. So if there's someone out there that has figured out simulation models using ANSYS or computational fluid dynamics for a specific chemical change, please, I'd love to hear from you. But we've done a lot of simulation work, but what we have done is worked with two-phase boiling immersion cooling providers and providers that are already doing boiling for cooling here. So we understand a couple of things. We need to understand the constraints, and we understand where they're lacking. And that's where we want to pull in. So although this is why we're here, Tess, we want to meet people like you. We want to meet the community to really get us on the next payload to do these experiments.
Great. Mark?
Well, great presentation, and I could really see your passion for this business coming through, so that's really important. Tell me a little bit about where the technology comes from. Is it a spin out? Have you licensed it, or is it being developed internally? Give us a bit of the history.
Yeah, so our background currently, the product that we sell is cold plates. We attach directly our copper cold plates onto high performance processors found in GPUs, CPUs of some of the most highest performance servers. So the cooling solution that we sell right now is cold plate technology. We are using our third-party solutions to fine-tune our liquid cooling solutions. But what we found is in our lab, we have the ability to fine-tune not just the cold plate, but also the two-phase immersion coolant. So we looked in ourselves, why don't we just develop the solution ourselves? So the basis is a nanoparticle solution It could be titanium dioxide, silver nanoparticles, metal nanoparticles in a glycol-based solution. And that's what we're currently testing. So we're looking to develop it ourselves.
Emily?
Yeah, I have a clarifying question, just so I understand. You're developing, you're using microgravity to develop the proprietary cooling system and then sending it back to Earth for Earth applications, like data centers on Earth and other cooling applications on Earth. Is that correct?
That's right.
Okay, cool.
Yeah.
So then my follow-up question, how do you do how do you compare developing a more performant cooling in microgravity, sending it back to Earth, versus just building more data centers that are maybe potentially less performant, but have a less expensive coolant? How did you think about those two options, and why do you feel very compelled that this microgravity is the key to unlocking better data centers in the future?
Great question. So it all depends on the data center application. Some of our investors previously through Techstars was Oak Ridge National Laboratory, and they run some of the largest supercomputers in the world. They run their workloads at 100% workload. So Emily, for use cases that run 100% workload, we're not geared towards all data center, we're geared towards the highest performance data centers on the planet. So where we really see our space is, yes, they'll be hosting data centers, they'll buy a server for $3,500, you use it until the end of lifespan, but we're really looking for a data center that uses their performance, they care about the 1% to 2% performance, and that's where we play. And that's where the optimizations of what we're doing with our coolant really matters. So for the power users out there that really care about that 1 or 2 or 3% improvement, that can mean a lot when it's 900 servers in the data room space.
I've seen a lot of entrepreneurs and pictures over the years, and I've never seen anybody nearly as enthusiastic about cooling as you are. Why is that? What is this?
Well, I got my degree in aerospace engineering, but I didn't really go to class as much.
Same.
I should have gone to class more.
Me too.
But what I was doing in college, I was building a business, building and selling high-performance PCs. I sold gaming PCs, workstations to scientists, even at my school. And what I found was, even from crypto miners to gamers to workstation and scientists, everyone cared about cooling. So that's how I kind of got into the space of cooling. And guys, I'm a tinkerer. Whether it's working on my car or working on PCs, I'm in the lab working with my team and my engineers on this stuff, because it's pretty damn cool when you can see a water-cooled system and you developed something that got that extra boost in performance. And that led to someone either saving time or money because they got their processing done faster. So that's where we geek out.
Oh, good answer. Anything left?
I got one more. Have you spoken to any data center owners about this, and what do they say?
We have, and currently that's the customers that we sell to. So we sell to high-performance server manufacturers, and the end user is data center. And when we're looking at some of the end user, we have 5 customers right now with a small to medium-sized data center. And what they're telling us is, you have the cold plate technology that you're showing a performance increase. For this next performance increase, we want you to show efficiency per square footage. So instead of you developing something where moving parts can fail or something can fail, why don't you go in with something where you can sell us on a basis of the actual material that we buy and implement. So don't just sell the coolers to us, but sell us a raw material that we can use with our current existing solutions, which is the coolant. So that's what we're learning.
Tess has one last quick
question. So I don't
question.
have a question, but you asked for help to get up there. And I think I see Sven from ISS Cases in the audience, who can help you get your payload up there. He controls experiments that go up and down. So that is Sven up in the audience.
Thank you, Tess, for the call out. I appreciate that.
That was very nice. Give him a round of applause. And I'll take this moment to say that all these companies presenting here are also exhibiting out behind this ballroom too, so go meet them and say hello. And last, we have one more company. The last company presenting is Plasmos. Presenting for Plasmos is Ali. Ali, come on out. All right, you have 4 minutes. There's your clock. Starts now.
Thank you. Hi, familiar faces here. My name is Ali Bakhtasar, founder and CEO of Plasmos. We are building reusable third stage, similar to how SpaceX built first stage, second stage reusable. We are building a third stage. well, my background, I've built and flown over 200 rockets, burnt myself twice as well, which is not written there. I think it should be. I've been a director at Airbus when I was 25 years old, sold my first company, actually 8 months ago, so that also has to be corrected, yeah. Recipient of Einstein visa within 2 weeks after I applied. I think the US government is pretty fast. So the problem I'm trying to solve is satellites can't still get to their final orbit. As SpaceX is building this giant infrastructure to launch satellites into, or payload into different planes in space, and as you can see there, from 1957 to 2021, it has been a pretty crazy increase of number of satellites. Just 2021, about 1,700 satellites being launched there. They can't still get to their final destinations, and if they can, it's pretty expensive. So what we think is that the answer is build a reusable spacecraft to meet this demand. And that's kind of what we are trying to do. So with that, I'm introducing Space Truck. Truck, space, space truck. So what that is that you can put payload around it, which can carry around 325 kilogram payload around it, can carry up to 20 kilogram payload inside it, and the entire vehicle is 3D printed and can weigh almost 60 kilogram only. It's SPA agnostic, can sit on any vehicle, can sit on a SpaceX 15-inch SPA ring, and can sit on a Virgin Orbit system as well. And with that, we can get you to specific destinations or bring back a payload. The market for that in the next 10 years is anticipated to be 15,000 satellites to be launched. Out of that 15,000 satellites, we are expecting to charge about $500K for each of those satellites or launches, and that comes to an $8 billion market. We move fast. I move fast to the United States, but also the company is moving fast. From the ideation to where we are, we built a very special engine which hasn't been done before. It's working in electric mode and chemical mode, so sort of like Prius in space. And we ideated with that, we designed it, we manufactured it, we tested it, it works. And now we are manufacturing the first spacecraft, which is being demonstrated on 10th of February, exactly 1 year after I have got to the United States. And we are launching this system in January 2024 to space to demonstrate its capability. So everyone is invited. Thank you.
All right, thank you, Ali. Emily knows a few things about reusable spacecraft, so let's start with her.
Yeah, sure. Thanks so much for presenting. This was an awesome presentation. I have a question about how you think about the role of this, the product, a third stage like this, relative to space tugs, which there are a lot of companies that are building tugs that stay in orbit and will rendezvous with a satellite to take that satellite to a higher orbit, and you don't actually need to launch that. Like the pitch is essentially you don't need to launch that extra mass. And so I'm curious how the economics differ. Like, why have you gone with a third stage rather than actually a tug that exists in space and does repeat missions? Yeah, would love a little more color on that.
Yeah, so I think those companies have a great mission, but I also see that it's pretty hard when I look at companies that manufacture satellites, and when I go in their clean room and I'm like, oh, holy shit, this is really hard to move. It's very sensitive equipment that you want to touch on. The center of gravity in every satellite is different. So when you look at those elements, I saw a hardship in designing a universal system that can grab any satellite and tow them to another destination. So I said, well, why don't we build a spacecraft that is super lightweight, or a spacecraft is very light, and integrate things on the Earth, launch it to a space, and then bring back the spacecraft so customers don't have to pay for an entire system to get up there, which is probably what's going to happen in the first years of these tugs being launched. So I wanted to be kind of a bit greedy in the business economics to say, I want to get the revenue while we are proving out even the concept. So even if the reusable part doesn't work, the system is very cheap because the engine, tanks, the whole thing is printed in one print, 170 hours. So for us, it's like, well, let's make that with the engineering manufacturing side of it efficient enough so we can get value out of it. And on the other side, we can deliver things in where they want to go and bring back our system. And the economics are actually very interesting. Happy to dig into the details of that as well.
Great. Mark?
Well, you've got my interest, particularly that you've already built and sold another business.
Thank you.
So that's good. And I like the way that you're seemingly doing everything very quickly. It's quite incredible the time frame that you've set for yourself, which I fully support, doing things quickly. One of the things that you said that really interested me was about bringing the payload back. Did you mean that this same vehicle can actually come back to Earth?
Yeah. So,
because that's a big market in its own right, I believe.
It's a big market in its own, and it has got, since we started pitching this concept as a generic concept, we've got customers that are actually interested to say, hi, I'll give you this payload, you can do on-orbit servicing with it, and you can bring it back. Or we can give you this payload, you can bring it to another destination since you can land it in a controlled way. So it's both big markets. We are really focused on building that universal technology that can land. My focus, my background is also partially in AI, so my interest is to get the data for reentry, kind of double down on that in the long run, so we know how to deal with reentries. And if we can handle reentry on Earth from orbit, we can handle reentry on any other planet as well. So that's kind of my vision for very far-fetched future of this company.
So the reentry is something much further down in your development pipeline.
Absolutely.
Tess?
I first want to clarify that your demo day isn't February 9th, 2022. It's next year, right?
Yeah.
23.
We haven't missed it.
No, demo 23. Sorry.
Yeah. But February 9th,
Yeah.
Sunnyvale. Okay.
Yeah.
It's coming up. Just wanted to make sure we didn't
Yeah.
miss it. What about the competitors in the space? You've had a handful of folks already go public, pave paths. What makes Plasmos different than some of the others that space tug and help deliver satellites to their
So most of the companies that are in this area, and thanks for the question, such as Launcher, Impulse Space, and Momentus and others, they are focusing on delivering a payload into a specific orbit, which is great. This is what we are also interested to do, but they are not reusable, which we are. So that's the main differentiator. So we bring back our system, they don't.
Great. Anything else? Any other questions? All right.
How much money are you planning to raise for this? And is the money required in order to deliver against your ambitious plan?
So $13 million for the first launch, if that's what you're asking. But for the entire, to get to the profitability, we are counting on close to $60 million to get the company on its own wheels.
Thank you.
All right, great. Thank you very much, Ali. Give him a round of applause.
Thank you.
Okay. I'm going to take the judges backstage, and we're going to confer and talk about these companies a little bit, each one individually. And again, just to clarify, we're going to judge the companies based on their potential for social impact or financial impact. Somebody might make a lot of money, and some people might change the world, and we put those on the same level. Now, if you have a space company or any other startup, this March, we're opening the applications for TechCrunch Battlefield at Disrupt for 2023. Please apply. Any stage companies will be fantastic. With that, thank you very much, and we'll see you guys next time.